Hello and welcome to Unit 4, Lesson 5. I've had a question in related rates, and I'm in Part 2. So question number 29. Small snake moves along a straight path at 2 meters per second, passing a 10-meter tall tree 4 meters away. How fast is the distance between the top of the tree and the snake changing 2 seconds later? So what I'm going to do is I'm going to look at this from one perspective. So here's my snake 4 meters away from a 10-meter tall tree. So we're looking at the distance change between the snake and the top of the tree. So we have our h. So it's going to be a Pythagorean theorem in 2 dimensions, but if we go with the top view, so the top view has our snake moving that direction at 2 meters per second. The tree is 4 meters away, and then the height comes out of the page. So what we're doing is we're doing Pythagorean theorem so let's go with hypotenuse 2, hypotenuse 1. We're doing Pythagorean theorem in 3 dimensions. So Pythagorean theorem in 3D. So we know that the Pythagorean theorem is the hypotenuse squared equals a squared plus b squared. And earlier, we know that in 3 dimensions, in 3 space, it's a squared plus b squared plus c squared. So that means that we are able to find the dimensions that go from one corner of a cube across to the other side by knowing A, B, and C. All right, so that's just finding the dimensions or the distance from one corner of a cube to another. So there's the formula, there's the relationship that we're looking for here. So we're going to go ahead and take the derivative. So we have 2h dh by dt equals 2a dA by dt plus 2b dB by dt plus 2c dC by dt. Right away the 2's will all cancel out. dH by dt, that's what we're looking for. We're looking at the distance, or how fast is that changing with respect to the snake and the top of the tree. So if I call the distance, the snake travels a, all right, that means that we know dA by dt. All right, that is how fast the snake is traveling. That means we can find A. So I'm going to start listing my information off to the side here. So I know dA by dt is the 2 meters per second. I know that the A value will be 2 meters per second times 2 seconds. So that means the snake has traveled 4 meters. Now, B. Let's call B the distance from the snake's path to the tree. We know the B value, it's 4 meters. How much, or how is the B value changing here? And when you look at how it's changing, dB by dt, that distance here is not changing at all. So that means dB by dt is going to equal 0, okay? Because the snake is traveling perpendicular to the path. C, we know, it's the height of the tree. It's 10 meters tall. All right. So how fast is the tree growing? dC by dt. So dC by dt is how fast the tree is growing. And in the 2 seconds, we're going to assume 0 meters per second. So that means that these last 2 terms are going to go to 0 because the tree's not growing within those 2 seconds, and the snake is staying perpendicular to the path. So that means that dH by dt will equal A dA by dt divided by h. So we do have to find h. I'm kind of making a mess here. So my h at that point in time would be h squared equals a squared plus b squared plus c squared. H squared equals, so we said the snake is 4 meters away. Didn't change his distance from the tree, and the tree didn't grow. So we end up with 16 and 16 is 32, 132, which means that at that point in time, H is the square root of 132 meters. So going back to our equation, plugging in our information, 4 times 2 over square root of 132 is the answer, meters per second. Does it match up with the answer provided? No, they've done a little bit, some calculations here. So it's just reducing or working with that radical. So at this point in time, you've got the full marks for calculus. Just for the pure mathies here, we'll work it down a little bit further. So if I multiply top and bottom by the square root of 132, and 132, and the square root of 132, again, I apologize for the mess here. Off to the side, the square root of 132 is equal to 4 times 33, which is equal to 2 root 33. So that means that that's equal to 4 times 2 is 8, and then times 2 root 33 over 132, which means I have 16, 8 times 2 is 16 over 132. So that gives me a final answer of 4 root 33 over 33 meters per second. All right, so there is the final answer. If you're in a pure math course, they'll want you to take you down that far. For my purposes, I am looking for, if you got to this point right here, you've got your full marks because you've done the calculus. Actually, yeah, at that point, this is also a good indicator right here. Tricky question. I kind of jammed stuff in so I could see everything at the same time, but that is the general process right there. If you have any questions, let me know, and I'll try to provide some additional help.